Greetings to the brightest audience in the country. This is Real Science Radio. I'm Fred Williams.
And I'm Doug McBurney, Bible student, science geek, and amateur comedian. It's good to be with you again, Fred, talking about real science on Friday.
Well, Doug, it's cold outside this time of year. I hope you have a sweater. And I got to say, Doug, I'm actually a huge fan of global warming, especially this time of year in Colorado as things start to get more consistently cold. So, I don't want global warming to melt all the snow off the mountains. Occasionally I might still go skiing. I know my daughter and son, they still love to do that. I just don't want this Marxist mentality, to just exert this pressure and power across the globe with global warming. That's the impression I get.
Well, one of the nice things about the Christmas season that it's a low point for the global warming propaganda, and I wonder, Fred, how much of that is real? So is it real that there's been an increase in the climate? Did I say increase in the climate? I meant warming? Is it warming or is it climate? That's all a bit confused. But how much of it is real, and how much is designed by tyrants and busybodies to take away our liberty and to amass power to themselves?
Yeah. So I was looking through some news stories, Doug, and one just popped up. It was Wednesday, just this week, and it's called "Capturing Methane from the Air Would Slow Global Warming. Can It Be Done?" And one of the things it says in this article, Doug, is we need to eat less meat and dairy. And, oh, by the way, cows burp up a lot of methane.
Oh, yeah, cows.
Cows. We've heard that one before.
Oh, yeah.
And, on this article, they've got a chart, which is interesting, of what causes methane. And the biggest contributor is wetlands, which is natural. And then the second biggest one is agriculture. Well, that's where, I guess we have to blame the cows and whatever else has to do with that. And then the third is energy. They're trying to show how man is causing all these problems. So, Doug, talking about climate change, a couple of years ago, I think it was December 2021, I believe, we had this really good speaker on at Rocky Mountain Creation Fellowship. For me personally, it was the talk of the year. And I really mean that. I'm not just trying to hype it, but it was so fantastic. And
yes, I remember I watched that on YouTube. Yeah, that guy was fantastic. Now there's a fellow who could help us sort out what's real and what's fake.
Well, I agree. And I wish we could have him on the show to talk about this methane. Well, you know what? As it turns out, I think we do have him. Dr. Paul Homan, are you on the line?
Yeah. Good afternoon, Fred and Doug. How are you doing today?
Paul, it is.
Hey, good to have you.
It's really good to have you. It's fantastic to have you join us on the show because you are the best person to ask on this. And I want to let our audience know that Dr. Paul Homan, he's been a student of God's creation since childhood. He received his PhD from the Naval Postgraduate School. He's married to Janae. He's a father of four, an avid outdoorsman, a runner, hiker, and a skier. So he doesn't want too much of that global warming either, but he probably still likes that when it's warmer. So Dr. Homan recently retired as the Director of Meteorology at the United States Air Force Academy. He is a regular speaker on the topic of climate change in both secular and church forums. Dr. Homan has served as a squadron commander and advisor to the Iraqi Air Force and worked on several international research initiatives during his career in the Air Force. He's often found playing in the snow somewhere on a mountain, but this Friday he's with us. And it's, again, Paul, great to have you here. And I see you're wearing a shirt, and I think that's your current employer, right?
Yeah, sorry, I have it down maybe below the camera a little bit. Currently I'm employed with an organization, a ministry to the military called Officers Christian Fellowship. My wife, Janae, and I have the pleasure of serving as their field representatives or staff to the Air Force Academy. So some things have changed, taken off the uniform, but still trying to love on people and serve our nation.
Yeah, absolutely.
Amen.
So
serve the nation, serve the Lord. Love it.
Yeah.
Amen.
Yeah, so, and you look far too young to be retired, by the way.
Oh.
So, Dr. Homan, what are your thoughts on this recent article? I'm sure you've got some ideas you can share with the audience on this whole bit about methane, which is just one component of global warming or climate change.
Yeah, we're going to get into it in the talk today. I'll give more detail. But the bottom line up front is methane is just such a small portion of the Earth's energy balance that, to be honest, I don't see how regulating any bit of methane has much to do anything with what's going on in our climate. I'll give evidence for that and the science behind that. We'll find out that it turns out other gases are also absorbing the same energy methane's absorbing, and you can't absorb the energy twice. So yeah, that becomes problematic, but we'll talk about why they might want to regulate methane as we come.
Okay. Yeah. Cause I noticed, in the article, they've got wetlands is the number one cause, which is natural process. And then agriculture, number two, that's where they're going to, take a shot at cows and eating dairy, eating meat and dairy and all that. So you mentioned, like an Earth's climate cycle or a balance.
Yeah, we're going to be talking about the Earth's energy balance today. I'm going to introduce the ideas behind that, because if you don't understand the energy balance in our planet, to be honest, I don't think you should really be talking too much about this topic. And yeah, times the Earth's energy balance becomes unbalanced. That's climate change. It's happening. It's always happened. It will always happen. And then I'm going to try to frame this today for us Christians on should we think about climate change in terms of a Christian biblical earth-keeping ethic.
Well, lay it on me. I want to know, what is Earth's energy balance, and are we precariously on the edge of something catastrophic regarding that?
Yeah, that gets a lot of news. We're not going to be able to cover everything in our short time today, but I do want to introduce what we're going to talk today is kind of an introduction to a larger presentation I'm going to be given again. You referenced one from 2 years ago, but I'm going to have the latest information and data. I'm going to be giving it at Rocky Mountain Creation Fellowship on the 8th of December at 7 p.m. at Littleton Baptist Church. So come out and join us. And they're telling me we're going to do a second radio show a week from today. So what we don't get to today, we'll try to cover on the 8th of December on this same radio show.
Yeah, so that's great. We're having you back
Awesome.
at Rocky Mountain Creation Fellowship. You can find out details on that at youngearth.org, and that's next Friday. So you have a whole week to plan on making it to that. You're going to want to see this. You'll be able to meet Dr. Homan in person and see all the slides he's going to have on this, plus just more material than we're going to be able to get to on the radio show today. So looking forward to that, Paul.
Yeah, me too. And Fred, I think you hit it on the head in your intro. Really what we're going to be talking about, if you want to have a context, is we're going to be comparing and contrasting, what is man-made climate change versus what is natural. And really what we're asking is, it's not that man can't impact the environment. I grew up on the Potomac River, 20 miles south of Washington, D.C., and I saw firsthand in the 80s, what a polluted river looked like. Man can certainly do damage to God's creation. But when we're talking on a global scale, when we're heated by a thermonuclear reactor here in our solar system, there's cosmic rays, there's volcanoes, there's a lot going on. And so we're going to look at, are the natural forcings bigger or are the man-made forcings bigger? And I'll let you decide for yourself if you come out to the presentation with the evidence I present.
That sounds really good. Yeah, it sounds like one of the energy sources you mentioned is the sun.
Yeah, we're going to talk about that a little bit today.
Yeah, that could cause global warming. I have to admit, the sun, definitely would play a role in that.
Yeah, so today, like I said, I'm going to really try to get into Earth's energy balance. That'll lead into an overview of climate change theory. And we'll talk about the role of greenhouse gases and like your methane we talked about a little bit already. And then I want to finish with going back to scripture and looking at what is a biblical earth-keeping ethic. And we'll contrast that with the assumptions of most of the modern environmental or green movement. Mm-hmm. Maybe next show, and certainly at the talk, we're going to inspect modern temperature data sets, both surface data sets, satellite data sets, CO2 data sets. And we're going to look at those climate models that they always say are doing so well, and we're going to verify them with reality, actual data. And when we compare the two, again, I'll let our listeners and our viewers figure out whether or not they think these computer models are doing well. And then what's always kind of neat to look at is, the sky is always falling in the media, So we're going to look at the trends of extreme weather, whether that's tornadoes, hurricanes, wildfires like we experience here in Colorado. And, everything's going to be data based. So we'll give you some information on that if you come out.
Well, I just wanted to just start things off with my big question. Which has a greater impact on the global climate? Is it the Chevy Suburban or the sun?
Yeah, we're definitely gonna try to answer that today. So I'm gonna punt a little bit as I get into the presentation here. For those that are, I'm trying to thread a needle here for those that are listening on the radio. I do have some graphics and some graphs, and I'll try to explain them as best I can verbally. But we will, you'll be able to go to the YouTube channel or come to the talk and see the graphs in person. I put up this thesis or hypothesis by Science Magazine they put out in 2010, which really gets to your question, Doug. And they stated, and I'm quoting, natural causes have always played a role in Earth's climate, but are now being overwhelmed by human-induced changes. There's your Chevy Suburban, right?
Wow.
So now the Chevy Suburban is bigger than volcanoes. It's bigger than the sun, according to Science Magazine. And they say that warming the planet will cause, these other climatic shifts at unprecedented in modern times, increasing, accelerating rates of sea level rise and alterations in the hydrologic cycle. Basically, what they mean by that is, more floods, more droughts, more hurricanes, more tornadoes, Chicken Little, the sky is falling. So we're going to step through, not all today are we going to be able to answer all of that, but we're going to try to look at the Earth's energy balance and get an idea of just even this greenhouse effect. Can man impact it and how much?
That's kind of scary for a little kid to hear. I can't imagine if I'm 11 years old and I'm hearing about overwhelming nature and all these disasters. And then, of course, in the modern media, because there's cameras everywhere, every day on the news, there's a catastrophe somewhere. And so I can see how this is freaking the kids out.
Yeah, I think we have to take a biblical point of view, though, that God's always in charge and we can still put our faith and trust in him. And the science will bear that out over the propaganda.
Yeah. So, and that's what we're looking forward to. You've got the actual science, and we can look at, this data. Everybody has data that they can analyze and how they interpret it. In the case of the climate change people out there that are pushing climate change, they use the data to shape their worldview and to push an agenda that ultimately, in my view, is it's a spiritual battle, because you're going to make lives more miserable in the long run. And, who's behind that kind of strategy?
Absolutely. If I could just throw out a couple definitions. I mean, we have a pretty educated audience, but, maybe the word climate is something you're not familiar with. I'm actually not a climatologist. I was a meteorologist. I guess I still am. And meteorology is just the study of the atmosphere, or most people would say it's the weather. And climate is pretty simple. It is just the sum or average, or it's the weather over time. So weather is what happens today, but climate might be what would you expect to happen on this day based on what's happened in the past, or, what might happen on this day a year from now or 10 years from now. So they're certainly related. And certainly in this, discussion and debate about climate change, we were talking before the show about how some of the vocabulary has shifted from global warming to climate change. Most of the time in the media, when you hear the word global warming or climate change, they're automatically inferring anthropogenic climate change or global warming or man-made. And, I don't make that assumption. As a scientist, we're supposed to look at all the evidence and not make assumptions before we look at the data. And so really what I think we'll look at today is the strength of the natural forcings versus the anthropogenic forcing or man-made forcings. And of course, as we've already alluded to, trying to scare the children, the vernacular has changed even more from climate change to climate crisis, climate emergency, climate catastrophe.
Right.
And hopefully I could put some of the fears at ease today as we start to look at how God created our wonderful planet.
Well, this kind of reminds me of a discussion I had a couple days ago with my son, Ryan and Abby. The millennials, or I guess it's Generation Z now I guess if you're at 20 or so, it's these new buzzwords they have. And one of them's gaslighting. Well, gaslighting makes me think of global warming. Maybe gaslighting is causing global warming. So I don't even know what this word means. I have to look this stuff up. And when I look the word up, it sounds like, if you look at the definition of gaslighting, it's like a psychological phenomenon where you're making the person you're gaslighting, feel like they're doing something wrong. I don't even know if I got the definition right, but it sure sounds like
pretty close. That's pretty close.
Well, it sounds like the media is gaslighting, the world and all this climate change, this climate crisis that you just said. That, to me, maybe that fits the term gaslighting. I don't know, but that's what it sounds like to me. And like I've said in the past, it's the left. They seem to live in a constant state of hypocrisy. They come up with these words and they love to use words like gaslighting. Well, it sounds like they're gaslighting us.
Well, Fred, how about we look at some of the science and we'll let the audience decide for themselves.
Sounds good to me. That's what we like here.
Love it.
We're real science on Friday, as Doug likes to say.
That's right.
There's a history behind that, Paul, an inside story that some of our listeners probably know about. But go ahead. Sorry.
No, that's okay. Well, for some of your listeners, I'm going to describe something that is actually incredibly complex, but we can boil it down to some simple things. So we're going to talk about the Earth's energy balance. And I know when I'm listening to talk radio, sometimes I'm driving. So if you're driving, you can't do this. But if you happen to be sitting at home, pull out a piece of paper. And really, we're just going to talk about the energy coming into our planet and the energy going out. And you can represent the energy coming into the planet as just an arrow coming in from space. And the energy going out is an arrow going out from the Earth back into space. And, if you're arrows, or if you're more mathematical or physics oriented, sometimes these arrows, we represent things called vectors. Mm-hmm. And, vectors have a magnitude and a direction. So in terms of magnitude, if your arrows are the same size, I think most third graders could get this. If the amount of energy coming into the planet is equal to the energy going out of the planet, I don't mean to try to stump you guys, but what would that mean in terms of our temperature? Would the temperature remain the same, or would it go up, or would it go down? What would you think if they were equal or in equilibrium?
Stay the same.
Yeah, it would stay the same. And so we could start to look at, what energy is coming in and what energy is going out. But, before we get into more of the specifics, if for some reason, well, we all know, where does most of the energy come from coming in? It's pretty much all coming from our sun, our thermonuclear reactor that heats our planet. And so if for some reason the energy coming in from the sun were to wane or go down a little bit, we would be at imbalance. So as long as more is leaving the planet than is coming in, that would cause a temperature decrease. Mm-hmm. If for some reason the energy going out of the planet were to decrease and the energy coming in were more, that makes sense. The temperature would increase. And really, this is the scenario we're going to talk about with greenhouse gases. Let me give you an analogy. When you're heating a pot of water on the stove, what's one of the things you do to heat the water faster?
Sit over a fire.
You can put salt in it.
Yeah. Well, we could talk about what that
salt
does. Yeah, that actually increases the boiling point to allow your food to cook at a hotter temperature. But that actually isn't what I'm going for. Most of us, you put a top on it, right?
Oh, yeah.
Right. So it gets.
Thank you.
I'm not the cook in our family. Just
I'm not even cooked.
Quick disclaimer.
Years, you stumped me.
Yeah. So guys, this is really basic thermodynamics, actually, though. So if you have the same amount of energy coming in, by putting that top on, you are slowing down the energy getting out. So there's an imbalance. So it'll heat up faster, or the temperature will increase. It's Colorado. It's cold. Wake up in the morning waiting for my house to heat up. Or you're watching your favorite show or sports on the weekends. Some of us will curl up on the couch and we'll pull up a blanket, right? You start to feel warmer. Is that because the house got warmer, or is it because you slowed down the amount of energy that's allowed to escape? That's what our atmosphere does. Our atmosphere, in a gross sense, not a direct analogy, but it slows down through greenhouse gases the energy leaving our planet. And so that if we have more coming in and we slow down what's going out, like putting a blanket on, then the temperature will increase. But what happens if you're still cold, right? You put a second blanket on. Does that second blanket have the same effect? In other words, when you put that blanket on, are you just going to heat to infinity just because you put a blanket on?
No.
No, right? You reach some new equilibrium temperature because as you heat up, your body will start to expel that heat. The blanket itself will warm up and it will eventually expel that heat. So you initially slow down the energy loss, but eventually it gets back to equilibrium and you achieve a new equilibrium temperature. If you put on another blanket, it'll go up a little bit. But guys, this is one of the reasons why I don't worry too much about catastrophes, is there's no way even if I put 20 blankets on, could I get to some infinite number of temperature?
Mm-hmm.
And the answer is obviously no. And each time I put on a blanket, each successive increase in that blanket, I get a less and less and less and less effect.
Yeah.
In other words, if I have 20 blankets on already, am I going to feel the 21st blanket?
Yeah, it's a smaller incremental effect. That's, interesting.
Right. So our Earth is the same way. And as we get into the more technical details, I think that's important to remember, because as we increase the quote unquote blanket, the greenhouse gases in our atmosphere, you're going to see that there's a ever decreasing effect when we increase the concentrations. So there's always a big effect when you go from 0 to some number. But as you continue to double that number and then double again, each doubling, you get a very less and almost minuscule effect. So bottom line, the Earth has to eventually try to achieve balance. And that's what causes all of our weather. Any questions for me before I get into any of the further detail?
Well, no, but that's a great analogy. You know, like when my son and I go to the Broncos game, it's usually fairly warm. Weather in Colorado is actually generally pretty nice. It's not like a lot of people watch Monday Night Football and they see it pouring down snow. The snow's there all the time. Well, anyways, as the game gets colder, sometimes we might need to put on a blanket on our legs, but having another blanket wouldn't help. I can see what you're saying. There's just an incremental advantage. And I guess my question to you is part of the global warming crisis, it looks like they're kind of playing a shell game in a sense that they're not telling people that global warming, it's so incrementally small as you get to more of these layers of this, I guess, greenhouse gas effect or whatever man-made causes that we may be providing. It'd be such a minuscule amount to something that's already, the huge balance part is already such a big part of the equation. You're only talking about barely moving the needle outside of the edges. Is that basically?
Yeah, I think you're hitting it straight on, and I'm going to show that here in the science and the data as we step forward. So if we could move on from just our basic model of what's coming in and what's going out, and maybe define a little bit of this. What's coming in is, again, primarily 99.999% of that is sunlight. We do get some cosmic or galactic rays coming from outside our solar system. But what's coming out, we can really break down into two things. So we're getting a little more complicated, but those two things is really reflected sunlight. So the sun that comes in and reflects off things like snow or clouds. It doesn't really heat up the Earth because it's reflected right out. So that's going out. And then the other thing is, as the Earth heats up, all bodies that have a temperature emit energy. And based upon their temperature, the temperature determines the type of energy they emit. And because the Earth in its temperature range, the Earth is emitting what's called infrared radiation, or IR. Sometimes we refer to this as long wave. And so if you're at home with us and you drew your diagram and you had in with the sunlight and you had out, you could just break this out into two things: reflected sunlight and infrared energy. And then we could play the little game that we've been talking. Let's say, for instance, the reflected sunlight were to decrease. Well, if you're decreasing the reflected sunlight, you're decreasing the outside. So again, there's more coming in than going out. So we're going to increase the temperature. Mm-hmm. How could this happen? Oh, maybe less clouds. That seems pretty natural. Maybe less snow. That could be natural, or it could be because of potentially because of some man-made warming or just glacial cycles. So that could be a reason for a temperature increase. But, we could also have the same thing. We could have more snow. We could have more glaciers in a particular year or a particular period of time, or more clouds. So now we have more going out than coming in if everything else stays equal, and we would have a temperature decrease. Actually, another way that could happen is volcanoes. We'll get into it probably in our next show and certainly in our talk at Rocky Mountain Creation Fellowship. Volcanoes. Volcanoes shoot a lot of aerosols and particles up into the upper stratosphere, which at the end of the day, the sun remains actually fairly constant with what it brings in to us. But all of a sudden now that sunlight doesn't even really make it to the ground. It's being reflected out. So in this kind of scenario, we'd have more out than coming in, and our temperature would decrease. But now if we look at our second out arrow, that would be the infrared coming from the Earth. We've already kind of introduced this with our talk about greenhouse gases. Greenhouse gases are gases that do not absorb the energy coming in from the sun. So the shortwave sunlight, the visible light, it passes right through these gases. It may be scattered. It may, get reflected downward or scattered. But once that energy hits the Earth, you feel this on your skin. You feel it on your car. The shortwave energy from the sun heats it up. And then your car or even your body, you get close to somebody who's really hot, you could feel the energy radiating off of them. And this is in the form of infrared energy or infrared radiation. And so what a greenhouse gas does, as this energy is trying to escape back to space, these certain types of air molecules will absorb that energy. That's kind of like putting on the blanket, where the blanket will slow down the escape of the energy from your body. When it absorbs it, it then releases that energy, still in the form of infrared, in all directions. Some of it is out to space, but some of it will be back down towards the Earth. This is what is known as makes the Earth warmer, the greenhouse effect. Mm-hmm. And ultimately, without the greenhouse effect, the Earth would be far too cold for life. So these greenhouse gases need to be they need to be on Earth in order for our Earth to be habitable. And it's kind of neat how God designed our Earth such that these things exist and keep us warm enough to have life on the planet.
Now, wait a second. Wait, did you say we need greenhouse gases? We need them?
Yeah, we need them. And we'll get into exactly what they are, which ones we should be worried about. But if we didn't have them, if we took greenhouse gases to zero, if we sucked out all that methane and all the others, and I'm not tipping my hand yet because we're about to talk about one of the biggest ones, we'd just be a big ice ball. Earth would be too cold for life.
Yeah. So it's important to know that greenhouse gases, we don't oppose those. They're part of God's creation.
Yeah. We breathe out greenhouse gases. That's kind of essential to life, that things that breathe produce greenhouse gases. So it's kind of a neat balance.
Yeah.
Every third grader needs to hear this, because this is something that by the way, Dr. Homan, I loved that when I mentioned the kids are scared, you immediately went to the Bible, which is exactly where anyone who's scared, that's where you need to go. But then on top of that, you're saying things that the average third grader can comprehend, and this could just calm them down and help them cope more effectively. So what are these blankets that we need, Doctor?
Well, so for those who have been trying to draw my diagram, we have sunlight coming in, and we have reflected sunlight going out and emitted infrared energy going out. It's really not any more complicated than that. But if you go on the internet, be careful. There's a lot of misinformation out there. But if you find a good graph, like I'm showing, the greenhouse effect, there all of a sudden is way more than 2 arrows or 3 arrows. But really, if you look, there's only 1 arrow coming in, and there's really only 2 arrows going out. The arrows going out, again, are reflected sunlight reflected from the atmosphere off of clouds or from the Earth's surface. And then the greenhouse gases emitting both down, out, and up. And so, finding this balance of the right combination of greenhouse gases is what the greenhouse effect is. And we can look at that. So I'm going to attempt for our visual audience to show a graph now. This is a graph showing the net flux or the net change in energy as measured by NASA satellites at the top of our atmosphere. So this is kind of putting into a short equation what we just have been drawing in arrows. And so it's the net flux. So flux is just a word for change. What is changing at the top of our atmosphere? And that is equal to the incoming solar, our downward arrow from the sun, minus the reflected solar, our upward arrow, and minus our outgoing long wave. And we live in such a wonderful time where we actually have this data. Really what this shows, this graph is from 2000 to 2023. It goes through this summer, that the net flux at the top of the atmosphere is going up. And so you're going, okay, so there's more. That means that there's an imbalance. And when there's an imbalance, and if the flux is positive, we would expect warming. So the satellites confirm, and we'll get into temperature data sets next episode. But, Paul Homan is not denying warming. I'm showing you a graph that says we should be warming because the net flux is going up. But this goes back to, we really as scientists want to say why. Why do we think it's going up? This is the first time I've ever used this graph that I'm about to show. And sorry for our listening audience. It's about as complicated as it can be, but I'll just state what I think this graph shows. Just a reminder, this graph is showing the three arrows that we've been talking about. So I even matched up the colors. So the incoming radiation is in red, the reflected sunlight is in yellow, and the emitted infrared radiation is in blue. And if I had to describe this graph, I'm going to show you, you pick any one of those. Let's start with the incoming shortwave. I've highlighted the zero line for the zero anomaly, so that would be kind of the average. You could see there over the last 20 years have been small dips in the incoming amount of radiation, small rises, and we are finishing in the last 3 or 4 years with an increase in the amount of energy from the sun. That makes sense. The sun is in a very active cycle right now. We're at what's called solar maximum. And so that's going to continue for another 2 or 3 years. And then we expect that to go down. The sun goes through roughly 7-year cycles. But what's really, really interesting is if you look at both the yellow and the blue lines, they're up, they're down, they're up, they're down. And I wanted to draw, for those who are able to look at the graph, attention to 2015. There was a switch before 2015. The outgoing shortwave was a positive. It was high on the graph. And the outgoing long wave was low on the graph. And I have to give credit. This is done by Dr. Judith Curry. I saw her present this on a similar show. And the real takeaway in this is that there seems to be these periodic natural fluctuations in how much infrared is being released, how much sunlight is going down. So if you look after 2015, all of a sudden we're very negative or low on the graph for the outgoing shortwave. That means we are reflecting less. So you could, if you wanted to say, we're having probably less clouds and less snow for the last 8 years or so, reflecting sunlight. Or maybe that's a lack of volcanic activity. There's a lot of explanations, but the bottom line, it's low. But if you look, the infrared radiation is in a positive anomaly. And if the infrared is positive, that means the Earth is giving off more heat. Well, if it's giving off more heat, that means greenhouse gases are not trapping that heat. And so it seems very odd to me that we are having highest concentrations of greenhouse gases over the last 8 years or so, but yet the Earth is giving off the heat. It's not trapping it. So according to the satellite data, through the infrared signal. So that would suggest that it's not the greenhouse gases that are warming us over the last 8 years or so, that it's the lack of snow.
Yeah,
and
which
lack
is
of ice, or I really think it's clouds. It's the weather. You have periods of higher cloudiness on the planet, and you have periods of lower cloudiness.
yeah. And the bottom line I'm hearing is it's a natural effect. It's not man-made. And yet we're being told that, hey, we got to get rid of our gas ovens. You know, that's heading to Colorado. I know that's in California right now. And so all these economic impacts based on something that sounds to me like a selective interpretation of this data, when actually, again, this is pointing to natural stuff. And Dr. Homan, are you saying then that we have been slightly warming since 2015, and it's probably because of fewer clouds, more snow, that kind of thing? Is that what I'm hearing?
Not drawing any definite conclusions. I definitely think fewer clouds could be one theory. Also, during that same time, we know that the sun has been increasing. So a combination of more sun and less clouds is what the data seems to be pointing to. But I want to show the very last data set. You heard a lot in the news this past summer in 2023 about, just all the wacky and crazy weather. And this data actually explains it and shows it. It's pretty neat. What people may not remember is we had this really, really big volcano erupt.
Oh, yeah.
The Hunga Tonga volcano erupted on January 15th in 2022. And I've already stated this. Usually volcanoes cause cooling on the planet. The reason for this is volcanoes spew a lot of ash and soot and particulate up into the upper stratosphere, and they block out that sunlight that we were talking about.
Yep.
But this volcano was very different in that it erupted under the ocean. And while it did spew some ash and things, what it spewed mostly into the atmosphere is water vapor.
Water vapor, yeah.
Water vapor. Whoa. Wait a second. You know what? We're out of time, especially for our radio audience. So, and I think the Hunga Tonga is a big issue, and I want to talk about this. We're going to do this next week, okay? Now, but before we go, I need to know on your graph, Dr. Homan, where do the Paris Climate Accords figure in? Where is that? How does that skew the data?
The bottom line, and you look at this graph, there's a lot of ups and a lot of downs in all these variables. I'll be honest, I can't see the man-made contribution. I'm not saying it's zero. I'm just saying it's so small that these graphs are showing that the natural forcings are just so much greater, that the Paris Climate Accords and burying the cow farts into the earth and all those things that are out there, I can't see the effect they would ever have, because things like the Hunga Tonga volcano can switch our climate on a dime, which we can explore more next time.
Yeah.
Yes.
Yeah, the human effect is like in the noise. I mean, how can you even detect it? So, well, we are out of time, but I'm glad that we plan to have 2 shows with you, Dr. Homan. We'll definitely have you back next week. And also you'll be getting ready to give your presentation at Rocky Mountain Creation Fellowship. So again, if you go to youngearth.org and check that out, you don't want to miss that show. Hey, and I wanted to give a really quick plug to Door County Coffee. It was my favorite coffee. And then I just happened by total, I guess, coincidence, I met the guy who started that business at the CMI Creation Ministries International Conference a few summers ago, and I just want to put a plug out for them, doorcountycoffee.com. They are Young Earth Bible-believing Christians who run that company, and it's a fantastic coffee. So Paul, looking forward to next week. We've got some teasers out there, so if you want to hear more about the water vapor caused by that volcano underneath the ocean, that'll be real interesting to see how it plays into global warming. We might get into a little bit more of the politics behind it. So, for Doug McBurney and Dr. Paul Homan, I'm Fred Williams of Real Science Radio. May God bless you.